Hello and welcome to 3D Loot Lab, and in this video we're going to go and take a look at the BEN2C High Performance Circular Flow Fan Duct that is for the Bambu Lab printers, the X1C, X1, or you have to select here the P1P or P1S. So we're going to look at some of the features, going to unbox it, set it up, remove the stock fan, install this fan, and then run a whole bunch of tests and take a look at those tests and see whether this fan duct is worth getting for your Bambu printer. But before we get into that, I would just like to do a small shout out to 3D Hub, who sent me this for free. I've used them for buying my Rapido parts and replacements, and a ton of filament, probably like 100 kg at this point, which is probably why they reached out, because we have a bit of a relationship already, and they asked like, hey, do you want to check out this new fan duct, the BEN2C, and just maybe give a shout out on social media? And I was like, hey, you know what? I'll do one better, and I would love to test it and post, and hopefully the results are good. So it's good just to mention that I did receive this for free, so I may be, and I probably am very biased, but but you know what? We'll the test results will be unbiased, and you will be able to make your own conclusions or draw your own conclusions from the test results. Okay, so first off, before we unbox, let's take a look at what is being described by BEN2C, which I guess is the brand here. I'm gonna guess the creator, his name is Ben. First off, yeah, it's a 360 circular flow design. As you can see here, just about this image, can't click on it here. It has 4 ducts instead, so it's quad duct instead of the stock bi-directional ducts. The air holes seem to be smaller and I guess more focused on the part. That's why it says patented technology that eliminates cooling blind zones, allowing for a maximum of 85-degree overhangs, and to ensure a uniform cooled print every time. Well, I have my 3D printer ready, and it goes up to 80. So, and you know what? If the overhangs are good at 80 degrees, I'm really very happy. Enhanced overhang performance achieved higher overhang print speeds and larger structures with temperature recommendations. Increased temperature recommendations, it seems, instead of the stock 220C for like PLA, which is what I use with my Bambu X1Cs in the background. It says you can push it to 225 to 235, so that's significantly higher temperature. Same goes for the PETG and ABS. ABS saying up to 300 degrees C. That would mean higher flow, yeah, higher flow is always great, and also stronger parts. And usually you don't, the higher you go, the worse the overhangs are, and the worse it is to remove supports. But they're claiming the overhangs with this will be just as good. I think that is the assumption here. And reduced noise, drastically reduced noise, putting it to 53 to 59 decibels, offering a quieter 3D printing experience. And I think that's because they're suggesting you can lower the fan speed and still get the same overhang effect as the stock. In fact, it says here no need for auxiliary cooling fan, and which is, if you know, it's very loud, especially if you leave the door of the if you have an enclosure, that is, on your Bambu printer, it can be quite loud. So this is made of lightweight and durable MGF nylon 12 for superior integrity and weight. So yeah, I should gotta remember that when you put this new fan on your Bambu, make sure to rerun the calibration. And I think that's it. And yeah, we can go straight to unboxing. Yeah. All right, let's quickly unbox this. All right. Don't want to rip it. Okay. Very simple unboxing. Instructions, I guess, telling you exactly how to change the fan duct on the tool head. Alright, seems pretty straightforward. We'll look at that later. What is this? There are 2 magnets in this bag.
may look like just one inside. Okay, there are two magnets. I guess this is part of the setup. And then some glue. Here, what do we, it's a USB? Maybe it has instructions on it. Is this some firmware? I'm not sure. I guess I'll find out. And there's a little screwdriver. Looks like pretty good quality. Let's take this all out. All right, here it is. Okay. That's what it looks like underneath. There's the front. This will be the front, I guess. And there's the 360 cooling. It's very close to the nozzle. You want to be as close as possible. And as you can see, the holes are very small. That's good. This is very accurate, very direct. And you concentrate that airflow. I guess that is the thought here. And you can tell this is like CF nylon, FJF, or I can't remember what type of printer it is, but it looks like it's 3D printed as well. And finally, these are these not the for the pre-existing wipes? Yeah, probably pre-existing wipers, and that's it. That's everything. Let's see. Alright, so here we have the stock fan mount, and I got here the nozzle, so you have an idea of how it would blow on there. So yeah, it's not super direct, but works fairly well, actually quite well. Now compare that with suddenly this bad boy. Oop. That looks pretty cool. Like it's all directly 360 right on where the nozzle is. Compared to that, which is just like, you know, right across the print.
All right, so this is what was on the USB. It has instructions as well as the nozzle wipe STLs, just in case you need to print that again. Show you a quick preview. Yeah, so you can print these ones with the supports, instructions about the nozzle, and then here it's got a really good installation video, much better than I can do. What you'll probably see here. Yeah, it goes right through how easy it is to take off the stock fan, take off the screws. I had some difficulty with all this, but putting in the magnets. So yeah, you can check that out if you buy the product. It makes it very straightforward, but I did find that my fan design was, as you'll see in the video, is different than what they have here, and that's just probably because Bambu Lab probably have different iterations of their stock fans as they've, you know, produced from what I have. I have like the Kickstarter versions, right? And there's also these a number of overhang videos, and they're actually really informative, really good.
Hi guys, my name
They
is
talk
Ben.
about
Tag
all
over.
sorts of
Please
techniques
to
to improve
see
overhangs,
how much we
a
have.
lot
Right
of
now we
slicer
have
settings I
in
can't
time
even go to
15
into
minutes
here,
30 PETG
including
equal
like increasing the
and
temperature.
PETG
Um,
printer.
like oh, let's check out this one here. This one has
Hi
all.
guys,
He's
I'm
got
Ben.
goes through a
Welcome to
bunch of
my
these
third
examples of
video. In
different
this
types
video
of
I'm going to introduce you
overhangs and
7
how to
examples,
basically,
and
you
these
know,
7 examples
print
are
without
going to
supports,
represent
and utilizing their
80% of
fan.
your daily
And the
printing
thing is,
process,
I didn't go
especially for
through.
structural
I just did very basic
printing process.
tests
And
on mostly stock settings in my bamboo slicer because that is what everybody has. But if you get this product, you can, I guess, try and use all the settings that they've suggested and they've tested. I've decided to just keep it mostly my slicer settings just stock. slight improvements, but I have increased temperatures of the materials, as you'll see later. And that's just about it for what's on the USB. What's this one? Oh, and this is their overhang test. But the overhang test I used, you'll see, is all 4 directions, because you want to check out that 360 cooling that they have.
Okay, so I gotta remove the stock fan, so after homing, I'm just gonna lower this all the way, or mostly down, get easy access. Ooh, oh, too much. Ooh, just enough. And then we can turn it off, and gently bring it to the front, take this off. Alright, so I've moved some of the silicone glue, so hopefully it's easier now. Oh man, I did not take enough silicone glue, or maybe this is a break from before, like, not sure why. As long as the wires are intact. The wire is tucked behind. Huh. I think I have to open this up from the top. So in the video, they have a P1P, so I don't know if it's different from mine. Also, these are like early Bambu Lab X1s. I think this one may even be a Kickstarter one. So maybe the routing of the wires are different, but in the video they just remove this, then remove the front panel. But my wire here goes all the way around to the back, it looks like, and it comes out here, so I think it's difficult to remove it this way. So actually, I did not need to remove this. So just double check on your end. All I will need to do is remove it from here. And so I'm going to be very careful in removing the silicone glue. I mean, do I even need to remove this? I feel like I can just remove this here while it's attached. I don't have to, you know, potentially ruining my wires. So I'm just going to remove it from here and attach what I need to attach, because I can just detach this, so I'm going to do that. Yeah, so I just looked at their video again, the BEN2C video, and they don't even have this here. So maybe yours does, it doesn't. Mine has it here. I don't think I need to remove it. I just need to remove these pins here and then push this down, remove the silicone here and push this down, and then rip this bottom part out, because this is what we're replacing. So that's what I'm gonna do right now. Gotta keep these screws in a safe place on the build plate. Actually, you know what? It's helpful to use a magnet to keep your screws from going everywhere. So I'm just using a magnet down there. That's it. Now I need to push this down. So in the video they use tweezers to remove the silicone, or whatever this glue is. Tough. Okay, there we go. And push this down. Oh, you know what? It just comes off. Like so. Alright. And then this later will be added onto here, and it looks like it will fit perfectly. But we gotta get the magnets in here. So we will take the magnet. Let's take one magnet at a time. This magnet, for instance. This magnet. We will take the pre-existing fan mount and we will just see what direction this is meant to be on. Right, so that means if that is the direction that the magnet's supposed to be to clip on, we mark it. I'll also get the other one here. And also mark it. So that marking point we want to see that when we put on the new fan duct. So get my tweezers again. Sorry if it's not focusing. All right. Okay, will this work? Okay, after fumbling around, I think this is how they do it in the video as well. That's why they give you this paper clip. Come on, focus. 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 There we go. And then you can just drop it in. Remove. And then they supply super glue, so we're going to use that. Just putting ample super glue on there. Make sure it goes in, right in. Okay, and that's it. Alright, moment of truth. Well, once I put that behind there. If I did this right, and if I know what I'm doing, yeah, that's correct. Yeah, the magnets are the right way around. Excellent. So now I can, go ahead and fit this on here. There are 3 slots. That went in nicely. And back to putting these screws in. Okay, and we have to loop it underneath the nozzle, and there it is. Looks very nice, very snazzy. Let's turn this bad boy on. Okay, and we're gonna test the fan in a moment while it starts up. In the meantime, I should do this when it's off. I gotta check to see just to see how the stock wiper works. Apparently that needs to be replaced. And let's turn on the fan. Part fan 100%. Wow. Ooh, that's powerful. Ooh, I should do the that water test. Alright, hopefully this is visible, but they say you have to install their own wiper here, because the dimensions of this is slightly different than the stock in terms of the being a little lower. And if we push this back, I can actually see that happening. Hopefully you can see it too. Alright, so that's the nozzle, but look, this is not the nozzle, this is the duct. Just like a millimeter or half a millimeter higher and it wouldn't hit, but I guess they chose that it has to be this way, to get the angle perfect. But you can see it is rubbing. It might be okay, but yeah, best replace, and that's what we're gonna do. Alright, so it's just a matter of removing one screw. I've never replaced this before. Haven't needed to. But here we go. Unscrew that. Oop. Great. Okay. And this is the stock one. And this one is the new one. And it is slightly lower the one they're given, and they're given files that you can use to print this yourself. I'll make sure I won't drop this one. Okay, it's just a PTFE2, and then insert into the new one. It can roll a little bit. Okay. And that's pretty tight. Gonna run this. Just gonna quickly check before I show you the other angle. Okay. So now we'll see that the fan duct is no longer rubbing. It's just above, and the nozzle seems to wipe just fine. Yeah, it's a pretty violent wipe usually, so I'm hoping that this won't break over time, but they do provide two. And STLs to print. Okay, this is purely for science. Actually, have a little sip of this water. Yeah. Okay, is that the middle? Alright, and let's try that again. 10, 20, 30, 40%, 50%, 60%, 70%, 80%, 900. Oh, cool. Not as crazy as I expected. Come on, the video promised like a tornado. Still pretty good. Again, don't do this. Don't do what I'm doing. I'm doing it so you don't have to do it. Alright, at this point it's just for laughs, but let's look at it at the with the stock fan. 10%, 20%, 30%, 40%, 50, 60, 70%, 80, 90, 100. I'll have to relook at the footage, but this seems a lot more turbulent. And it seems more spread. Alright, that's enough. Take a sip of water. Notice it's starting to knock. Hopefully it didn't knock off. This new fan duct. It seems to be stable now. So at the beginning I had this problem where the prints would just fail. They would knock off because as we got to the top and the overhangs got more pronounced, then it started deforming, and then the nozzle would hit the print and knock it off. So one, I had to add a brim to a lot of these, and then two, I had to increase the minimum layer time so that there's just that extra bit of cooling time, so there's less deformation. Otherwise, it just, with these going to 50 degrees and beyond, it increases the chance of just knocking off. So to maintain consistency for all the benchies, I just increased the minimum layer time to 10 seconds. And then I never had that same problem again. Alright, I finally finished printing a whole bunch of these benchies, and I noticed really good results with the ABS and inconsistent results with the PLA, and I realized that I was swapping between machines in my tests. So with the ABS, I did all on one machine, but with the PLA, I was like doing one or the other machine for the stock fan, and that's not a good way to run this. So I'm gonna have to redo my PLA benchies. On the one machine, I'm gonna have to swap back to the stock fan duct, rerun those tests, and then I can flip back to the BEN2C fan duct and compare just so that it's accurate. Because even between the same model printer, there may be a slight different airflow. Plus, I mean, I got this one 2 months before I got the other one there, so they were early models, so maybe there's not consistency in the fans. Maybe they changed out different types of fans. But yeah, I'm just gonna have to rerun those on here. So I should have thought of that before, but here we are. So taking off the new fan duct is easy enough. It's only 2 screws this time. And putting in the stock fan should also be as easy as clipping in. And there was 4 screws before. I'm only going to screw on two since it's like temporary. Come back, get the stock fan. Okay, well, it's partly in. And this one should do. Done. Oh, what an ordeal. Okay, we're finally here. The funnest part of this whole ordeal. It took me forever to do all these benches. If I just pan around, you know, there's even more that kind of out of scope now, but and tons of failed ones that I had over 30 of these printed. They take about an hour a piece, and you know, it just took days to do this and compile it and do it right. But yeah, we're at the fun part where I can finally take a look at these results. I took a little bit of a look, but I haven't looked in depth, so literally it's going to be on the fly, learning to see whether I guess I should pan out of here. I'll mention here that over on this side we have the stock fan duct benches, and then on the right over here we have the BEN2C new fan duct benches, and then we have sets of PLA, PETG, ABS, and then finally nylon at the top. I did a lot more PLA tests just because I do a lot more PLA prints, and most people also do that too. So I played around a lot more with the various settings to compare. And one thing to mention about like consistency, we'll take a look at consistency with just the stock settings 220 degrees C. Over here, I have 2 of the same at 220 degrees C, as well as 1 220 degrees C from a different Bambu X1C printer. And before we go into that, I'll also mention that these are my tests, and you know, it may be different depending on like the brand and even the color of the filament. So you know, this is not so your results may be different, but hopefully this, you know, the results are consistent enough among the material types that we can come to some conclusions about the BEN2C fan duct. So the first thing I'll go over is maybe just bridging. I just did a couple bridge tests, but I ended up just having these on the table here. Bridging has a lot more to do with the extrusion amount, the flow, as well as the speed of the bridging over the fan duct. So I don't think I would gain much by doing lots of testing between these 2 fan ducts in terms of bridging, and plus it would introduce a whole load of new tests. But as you can see, there isn't really much of a difference. At least I don't see much of a difference between these. And you know, it just blows air. Like I said, it relies on other settings. So put that out of the way, and as we were saying, we were going to go and look at consistency. So here, 220 degrees C for PLA. Okay, so the way this is going to work is I'm going to line these up by the X and Y, so the X and Y are exactly the same. And the reason why I chose this bench, it has all 4 corners, is because, you know, the BEN2C, it's supposed to be a 360 cooling, so it should have a different effect on each one of these compared to, say, the bidirectional stock fan duct over there. And the way these works is there is an X and Y symbol on here, so I know how these were placed. So we have to align these up, and then we can check the underside. Sometimes it's better to look at the top too, but as you can see, it goes from 10 degrees all the way to 80 degrees in terms of overhang for those who are familiar with it. So we'll turn these over, and we'll get nice and close. And again, this is 220 degrees C, and on the stock fan, and these, we're seeing how consistent the results are. and they seem pretty consistent. I mean, this one's a little worse, but it's pretty similar. Next up, this looks pretty similar. This looks a little worse again, but still very similar. Very similar. Very similar. And then if I was to compare with stock fan duct on a separate Bambu machine, line this up, okay. Again, this one's still really good. Well, still pretty consistent. Pretty consistent. Yeah, pretty consistent. They are slightly different, but not terribly different. So that's good news, because that means the rest of our tests we can maybe rely on saying that, you know, if we repeated each of the benches, we should get similar results. So we can then we're able to draw conclusions when we make comparisons between the stock and BEN2C fan duct. So I'll pick up the best piece of the 220°C for the default fan duct, and take the BEN2C, and I gotta line this up like I mentioned, and let's take a look. So this may be just been an anomaly, but yeah, this is actually worse of this angle for the BEN2C. Let's move it around. Here it's slightly better on the BEN2C. You can see that, like, that is at 60 degrees. We just have a little anomaly there. Here we start having some ripples here also at 60 degrees, but it's like a couple like 3 ripples, and then another some more overhang anomalies here, whereas this seems just smoother. In fact, man, at 70 degrees C, it seems very smooth on the BEN2C, smoother than 70 degrees on here. Still pretty close. We'll speed this up a little bit, but very similar to here. 70 degrees looks really good at the BEN2C. Overall better on the BEN2C. BEN2C looks really good here. Overall is better, not hugely significant, but it is better on the BEN2C for 220°C stock, Bambu slicer settings. Next up, I tried raising the temperature to 235, which is actually what BEN2C says you can raise it to 235, better flow, but theoretically be worse overhangs. Let's line these up. Okay. Oh my gosh, wrecked everything. Okay, no. Okay, so BEN2C is on the right again. Very similar. I would give it to the BEN2C. Also very similar, but this one's easier to tell. It's better on the BEN2C. Better on the BEN2C. This is probably the most significant overhang for the 235 where I see a difference. Better on the BEN2C. Again, not crazy better, but still better. That's good news. I would expect that. It does look like it angles the air better. Okay, so that's 235C. So what happens if we start reducing the fan? So what I did here is I reduced the fan by 50% and the auxiliary from I reduced it in half as well, and this is at 220°C. And BEN2C did mention that you can reduce the fan with their fan duct because it's that much more amazing. But let's take a look. So I gotta line this again, and let's take the first. Okay, so it's worse here on the. It seems to be like sometimes the anomalies are worse on the BEN2C on the front. But yeah, mind you, this problem here is at 60°C with with the stock fan duct, we already have a problem at 50. So, although this looks worse because there is this like it's what would I say, this is coming out more, this single extrusion line, it's at 60 degrees C, but the first time you see a problem here with the stock fan duct's 50. So yeah, make of that what you will. So yeah, and we're moving on to this side. The cooling just seems better than on the front. This would be on the left, and yeah, this definitely goes to BEN2C. It's actually really nice, all the way up to 70. Here you can see there's problems on the stock fan, and then moving on to the back. Yeah, this goes to the BEN2C. It's not as smooth as the last overhangs, but this is pretty good. This is 60. 60 have bad overhang problems on the stock fan, and then finally, yeah, it is quite nice on the BEN2C, like with 50% fan. So it looks like it's working. And then we have problems here starting at 50 on the stock fan and pretty bad at the 70. Okay. So, and then yeah, and then this final test here, I just regular fan speed but no auxiliary fan, and the auxiliary fan is what's really loud. So being able to turn that off is very helpful in terms of noise reduction. And that is something that BEN2C highlights. So let's see if you can actually turn off the auxiliary fan, or what results we can expect. So the front seems pretty similar. It may be worse on this one on the BEN2C at 60. This is also 60. It's pretty close actually. I would say this is the same. Very similar except for this part. So this also goes to BEN2C. Slightly BEN2C, but it's pretty much the same. Very similar. Here, same deal. Very similar. I mean, what angles? This is 60. This problem here is 60. Yeah. Yeah. It's very similar, but it is better than BEN2C in this. Okay, and now moving on to PETG. So, oh yeah, so this is an extra. Yeah, actually, I noticed. Yeah, I'll mention that in a bit. But so this is PET at 280 degrees C. Let's line these up. Oh, it's kind of hard because it's clear to see where the X and Y's are. Okay, so here we go. Now this might be harder to see. Now these overhangs came out really nicely on both. It's just maybe just PET or just this brand and it being clear. It's a lot nicer than the PLA. So much so I don't really notice a difference. Yeah. I do not notice much of a difference. Yeah, and then the final part. Yeah, it's exactly starts bulging at 70 for both. So I did with this particular brand and with PET, I don't see a difference between these two with stock settings and 80 degrees C. And I also tried 285 at 50% fan on the stock duct, and as you can see, it's also pretty good. So, you know, I didn't bother trying BEN2C because I mean, like, stock fan, and you know, it's already having superb overhangs with this. So yeah, that is for PET. Again, not too noticeable any difference there. and then ABS. And I was excited when I initially saw ABS. We'll take a look again because I did see some significant differences there. So we'll start with ABS at 70 degrees C. Let's line these up again. So, okay, ABS. Again, stock fan is on the left, and this is the front. It looks pretty good on both, but BEN2C is other than this, but BEN2C it looks superior. BEN2C looks superior here. It doesn't have this. It's very consistent all the way up until 80 degrees. This time around on the BEN2C side, we start having we have an issue here, but it's the same on the stock fan duct. Overall, it's still nice on the BEN2C, and really nice on the BEN2C here, and worse on the stock. All right, and what about if we up it to 80 degrees C? Let's line this up. So ABS at 80 degrees C, and it's and like this print's a lot hotter, and this is the ABS was printed with the door closed, and the chamber heat was probably like it was like 48 degrees C, so you know that helps reduce warping, but it also makes it you know, overhangs worse. So it's very nice to see that these overhangs are coming out so nicely. All right, so what do we have here? This is the front. And the BEN2C is very smooth all the way up to 70. There's some small rippling here. I think it's at 60. Yeah, at 60 for the stock fan duct. So BEN2C for the win there. BEN2C is really nice here compared to the stock fan. Again, BEN2C is clearly the winner here. This one's a little closer, but BEN2C is still the winner. That this rippling is a little worse than what's over on here. Yeah, and that's it. So ABS, at least with this particular brand and the color black, it was more noticeable that the BEN2C did a better job of the overhangs. And then we go with we'll take a look at the nylon, and this looks really ugly for both of them. And you know, this wasn't the best test actually, because when you slice it and with the settings I think it should be in stock settings for this, it really has like zero fan or no fan, and it only produced fan right at the overhangs. So there's the zero fan for the whole part. It's a closed chamber. It ends up going to around 55 degrees C on my X1C. So the heated chamber is hot, and again, like no fan and just very little fan on just the overhangs. It ends up looking super ugly, as you can see, on both. But let's just compare anyway. So in this case, the front, the BEN2C looks worse. It seems like the front seems to have problems, if there are any problems. That's pretty close. This might be like just anomalies. But yeah, it's probably better with the stock fan duct. This one is better with the BEN2C, and this one's a little harder to give a verdict. It's pretty close. It's like the same, but again, I don't think this was wasn't a very good test. Just there's like no fan going, and this is a fan duct, so this is what's being tested here. So yeah, if there's no fan, then you can't expect you know, different results or for amazing results from the fan duct. So so yeah, there you have it. So to summarize, did a lot of testing with the PLA, and I do see differences where the BEN2C is better. In some cases, it was in a lot of cases it's not so significant, and then in some cases it is pretty significant. With PET, I saw no difference. With ABS, that's where I saw a significant benefit in the overhangs. And yeah, so would you want to buy this and use this? Well, I think it does work, and and some people may say it's expensive, but it really depends on your needs and whether you really want to push your cooling that much further. Because like I buy nozzles sometimes, not the Bambu, but for my like rat rig, it's like $25 for a single nozzle because I need it like to have the extra flow and it to be extra quality. Um, and those things run out, right? This thing you buy it once and then it's done. It doesn't wear out, so there's that to consider.
And that's pretty much it. Thank you for watching this video, and hopefully it's been fun and informative. And if you've liked it that much, I hope you consider subscribing. And while filming this video, I started experimenting with reducing the noise while still getting great overhangs, which is mainly modifying the fan on the part cooling fan, the auxiliary fan, and closing closing the door, and I got some interesting results, and I will be putting together another video where I think we can optimize the overhangs and the fan speeds and greatly reduce the noise, because if you have one of these printers, it's amazing, but they are really loud, especially if you're sitting in the same room as one of them. So that should be interesting. And yeah, so that's why you should subscribe. All right, and yes, thank you.